This is the EdExcel GCSE 9-1 Maths Paper 2, which is a calculated paper, and it's from the Specimen Set 1 papers. Question 1. We have to make t the subject of the formula w equals 3t plus 11. Well, first of all, if we subtract 11 from both sides, you'd find 3t to equal w minus 11. Now if we divide both sides by 3, you'd therefore find t to equal w minus 11 over 3. Question number 2. 3 companies sell all the same type of furniture. The price of furniture from Pools Inn of London is £1,480. The price of furniture from Jardins of Paris is €1980. The price of furniture from Outways of New York is $2250. The exchange rates are £1 equals €1.34 and £1 equals $1.52. Which company sells this furniture at the lowest price? You must show how you get your answer. Well, here I think it will be a good idea to make sure that the units of each of the prices is consistent. For example, we can convert everything to pounds. So for London, we know that the price is 1480. For Paris, we need to convert the 1980 into pounds, and we can do that by dividing this amount by 1.34. So we have 1980 divided by 1.34. So if we work this out, 1980 divided by 1.34, you'd find here we get 1477.61. Okay, and for New York we have 2250 divided by 1.52. This will convert the dollars into pounds, and if we work this out, 2250 divided by 1.52, this is equal to 1480.26. So now if we compare all these prices, we can therefore conclude that Jardins of Paris has the best value for money because it has the smallest price out of all 3. Question 3. The time series graph gives some information about the number of pairs of shoes sold in a shoe shop in the first 6 months of 2014. So that's what we see here. The sales target for the first 6 months of 2014 was to sell a mean of 96 pairs of shoes per month. Did the shoe shop meet this sales target? You must show how you get your answer. So we need to find the mean, and you can see here that there's 1, 2, 3, 4, 5, 6 months. We can find the total pairs of shoes by finding out the total from January, February, March, April, May, June, adding them together, and the mean is found by the total divided by the number of months, 6. So you can see we have 110 from January, we have 84 from February, we have 78 from March, we have 94 from April, we have 90 from May, and we have 120 from June. And then we will divide all of this by 6 to find out what the mean is. So if we work all of this out, we have 110 plus 84 plus 78 plus 94 plus 90 plus 120 divided by 6. It turns out here, indeed, we do get 96. So therefore we can conclude the shop met their target. Question number 4. The grouped frequency table gives information about the heights of 30 students. That's what we see here. And for part A, we have to write down the modal class interval. Well, the modal class interval refers to the most common. The most common is the one with the highest frequency. The highest frequency is 10. That corresponds to a range of heights 160, which is less than h, which is less than or equal to 170. And now for part B, the incorrect frequency polygon has been drawn for the information in the table. We have to write down for part B 2 things wrong with this incorrect frequency polygon. Well, first of all, you'd find if you look over here, 130 has been plotted, but what we should have done is plotted the midpoint of 130 to 140 instead. So that's one error. Let's just write that down. So we should be plotting the midpoints of the interval, and the other thing that's wrong is this line over here closes the endpoints, and we should not be doing that. So the polygon should not be closed. Question number 5. At 9 AM, Bradley began a journey on his bicycle. From 9 AM to 9:36 AM, he cycled at an average speed of 15 kilometers per hour. From 9:36 to 10:45, he cycled a further 8 kilometers. We have to draw a travel graph to show Bradley's journey. So, first of all, you can see here that we've been given a speed and we've been given a time. But the problem is the units aren't consistent so far. Here we have kilometers per hour, and here from 9 AM to 9:36 AM we have minutes. So first of all, we can convert the 36 minutes, of course that's from 9 AM to 9:36 AM, into hours. So to go from minutes to hours, we would have to divide by 60, and to go from hours to minutes, we would have to multiply by 60. Now we also know that speed is equal to the distance over time. So with this we can find the distance he travels from 9 AM to 9:36 AM. And we can do that by multiplying the speed by the time. So if we work this out, for the first part of the journey, so from 9 AM to 9:36 AM, we have the distance, which is equal to the speed, 15, multiplied by the time. Well, here we've got 36 minutes, and that in hours we have to divide by 60. So if we work out the distance, 15 times 36 over 60, that's 9. So we have 9 kilometers. So from 9 AM to 9:36 AM, the distance is 9 kilometers. So let's show this. Well, here you can see for our time axis, halfway between 9 AM and 9:30 PM, that's going to be 9:15. Halfway between 9:30 and 10 AM, that's going to be 9 45, we want 36. So here 15 minutes is represented by 5 little squares. So 1 little square is 3, so 2 will be 6. So 2 squares across will be 936, and the distance is 9. So here is where we have our first point. So let's just join all this up with a straight line, as we see here. So this is the first part of the journey. And for the second part, from 9:36 to 10:45, he cycled a further 8 kilometers. So therefore, from 9:36 a.m. to 10:45 a.m., the distance is equal to 8 kilometers. So 9 plus 8, that's 17. So 10:45, he ends up travelling a total distance of 17. So here we've got 16, 17 is over here. So let's join these up with a straight line, as we see. Rather, we just undo that. 10:45 is here, and 17 is, well, here we've got 15, 16, 17 is here. So here is the correct graph for part A. Now for part B, from 10:45 to 11 a.m, Bradley cycled at an average speed of 18 kilometers per hour. We have to work out the distance Bradley cycled from 11:45 to 11 a.m. Well, here the distance is equal to the speed. So the speed here is 18 kilometers per hour, and then the time, well, 10:45 to 11, that's 15 minutes, and then we divide this by 60, as we saw here, to convert it into hours to make sure the units are consistent. So if we work this out, 18 times 15 over 60, this is 1/4. 18 times by 15 over 60, this is 9/2, in other words, 4.5 kilometers. So here we've got 4.5 kilometers. Question number 6. Toby invested £7,500 for 2 years in a savings account. He was paid 4% per annum compound interest. How much money did Toby have in a savings account at the end of 2 years? Well, here, if the interest rate is 4% per annum and he's investing for 2 years, the total amount of money he has at the end of the 2 years, well, we've got the original amount, which is 7,500, and then we will multiply this by 1 plus 4/100 to the power of 2. So if we work this out, 7,500 times by 1.04 to the power of 2, it turns out here we get 8,112. So therefore, he has £8,112. Question 7. Becky has some marbles. Chris has 2 times as many marbles as Becky. Dan has 7 more marbles than Chris. They have a total of 57 marbles. Dan says, if I give some marbles to Becky, each of us will have the same number of marbles. Is Dan correct? You must show how you get your answer. So let x be the number of marbles Becky has, so B equals x. Chris has 2 times as many marbles as Becky, so C is equal to 2x. And Dan has 7 more marbles than Chris. Well, if Chris has 2x marbles, Dan would have 2x plus 7 marbles. So the total number of marbles they have is 57. So we can form an expression from this for the total. The total number of marbles they have, we have x plus 2x plus 2x plus 7. So here we get 4x plus x, that's 5x. And then we have the plus 7 as well. So in other words, 5x plus 7 is equal to 57, because there's 57 marbles in total. So therefore 5x, if we subtract 7 from both sides, this is equal to 50, and therefore x is equal to 10. And knowing that x is equal to 10, we can therefore conclude that Becky has x marbles, so she has 10. Chris, he has 2x marbles, so he has 2 lots of x, which is 20. And Dan has 2x plus 7, so here we've got 2 lots of x, that's 20, plus an extra 7, that's 27. So these are the number of marbles they have each. Now Dan is saying he's going to give some of his marbles to Becky, and if he does that, all of them will have the same number of marbles. Well, if they all have the same number of marbles, they all need 20 each, because Chris's marbles have not changed. And if they have 20 each, that means that they need 60 marbles in total. So he's wrong. So let's just write all that down. So if they had the same number of marbles, they would need 20 each, in other words 60 marbles in total. And therefore Dan is incorrect. Okay. Question number 8. Here is a diagram showing a rectangle ABCD and a circle. BC is a diameter of the circle. We have to calculate the percentage of the area of the rectangle that is shaded. Give your answer correct to 1 decimal place. So we need to calculate the area of the rectangle, and then from that find the percentage of the area of the rectangle that is shaded. So first of all, we would have to find out the area of the rectangle. The area of the rectangle is equal to 16 multiplied by 19, which is equal to 304 centimeters squared. Now we also need to find out the area of the semicircle. We'll show that here. So we need to calculate this shaded area, and for us to do that, we can recognize that the area of a semicircle is half the area of a circle. So we need the radius of this. So here we've got the radius, which is half of the 16, which is 8 centimeters. So therefore, the area of the semicircle is equal to 1/2 of the area of a circle. Now area of a circle is equal to pi r squared, so half of that we have half pi r squared. Now the radius here is 8, so we have a half pi lots of 8 squared, so 64 times a half, that's 32. So here we've got 32 pi centimeters squared. And with this we can find out the shaded area by subtracting the area of the rectangle from the area of a semicircle. So for the shaded area, that's equal to the area of the rectangle 304, take away the area of the semicircle, which is 32 pi. So if we work this out, 304 take away 32 pi, it turns out we get 203.4 etc. So we have 203.4 etc. centimeters squared. So we need to find out the percentage of the area of the rectangle that's shaded. So therefore, the percentage is equal to 203.4 etc. over the area of the rectangle, which is 304, and of course we need to multiply this by 100. So we divide this by 304 and then we multiply by 100, and it turns out to one decimal place we have 66.9%. Okay, so let's just clear things up here. Here we've got the percentage shaded being equal to this amount here. So therefore, to one decimal place we have 66.9 centimeters squared. Question 9. The diagram shows the positions of 3 points A, B and C on a map. The bearing of B from A is 70 degrees. The angle ABC is 50 degrees. AB is equal to CB. We have to work out the bearing of C from A. So, let's see what we've been given. We've been given that the bearing of B from A is 70 degrees. So, the bearing of B from A, so we're starting at A, going to B, this is 70 degrees. So we have 70 degrees here. And we also know that AB is equal to BC, so this side is equal to this side. So because of that, we have an isosceles triangle. Let's just write this down. The triangle ABC is isosceles because AB is equal to CB. So because of that, the base angles on an isosceles triangle are equal, which means this angle is equal to this angle. So therefore, we can conclude that the angle BAC equals ACB. And if we work this out, 180 take away 50 divided by 2 is 65. So this angle here is 65. This angle here is also 65. So let's show that here we've got 65 degrees, and here we've got 65 degrees. Of course, here we've still got the 70 degrees. Now, we need to find out the bearing of C from A, so starting at A going to C, we can therefore conclude that the bearing is equal to the 70 degrees plus the 65 degrees, which is 135. Of course, remember we need to measure from north clockwise, so we have 135 degrees. Question number 10. The graph shows the depth D centimeters of water in a tank after t seconds, and we have to find for part A the gradient of this graph. Well, the gradient is equal to the change in y over the change in x. So therefore, the gradient is equal to the change in y. Well, here we've got the point 210. And then here we've got the point 0 in terms of the y coordinates. And the change in x, we have 0 take away 140. So if we work this out, 210 divided by minus 140 is minus 1.5. So So the gradient is minus 1.5. Okay, so what we need to do for part B is explain what this gradient represents. Well, here you can see that the depth is changing with respect to time, so therefore for what this gradient represents, well, it would represent the rate of change of depth of water in a tank. Question 11. Finley plays 2 tennis matches. The probability that he will win a match and the probability that he will lose a match are shown in the probability tree diagram that's shown here. And for part A, we have to work out the probability that Finley wins both matches. Well, if he wins both matches, he wins this one and he wins this one. Probability that he wins and wins, that's equal to 0.7 times by 0.7, which is equal to 0.49. So we have 0.49. For part B, we have to work out the probability that Finley loses at least one match. Well, here, the probability that he loses at least one match is equal to 1 minus the probability that he wins both matches. So here we've got 1 minus 0.49, which is equal to 0.51. So we have 0.5. Question 12. For part A, we have to find the reciprocal of 2.5. Well, reciprocal means 1 over something. So here, the reciprocal of 2.5 is equal to 1 over 2.5, and if we work this out, we get 0.4, and you can check that on your calculator. Now for part B, we have to work out the cube root of 4.3 times tan of 39 over 23.4 minus 6.06. Give your answer correct to 3 significant figures. So what we need to do is work out what this value is using our calculator. So we've got the cube root, so press shift and then the square root button. So this brings up a cube root, and then we want a fraction. On the numerator, we have 4.3 times by the tan of 39. And then on the bottom, we've got 23.4 minus 6.06. So here we get 0.585, 5934233. And therefore to 3 significant figures. Well, if we look at the third figure, the figure after it is 5 or greater, so we round this third one up. So here we get 0.586 to 3 significant figures. Question 13, we have to show that 3x minus 1 lots of x plus 5 lots of 4x minus 3 expands to give 12x cubed plus 47x squared minus 62x plus 15 for all values of x. So what we can do over here is multiply through. Well, here let's just keep the 3x minus 1 as it is, and if we expand with these other two brackets, we have x times by 4x, which is 4x squared. Then we have x times by minus 3, that's minus 3x, and then we've also got 5 times by 4x, so we've got minus 3x plus 20x, that's 17x, and then we've got 5 times by minus 3, which is minus 15. And now if we expand these out, we have 3x times by 4x squared, so here we will have 12x squared. Then we have 3x times by 17x, that will give 51x squared, and then we have as well the minus 1 times by the 4x squared. So altogether here would have 47 x squared. And then we've got the 3x times by minus 15, and then we've got minus 1 times by 17x. So here we've got minus 45x minus another 17x, that's minus 62x, and if I just grab a different colour, we now have minus 1 times by minus 15, which is plus 15. Hence, this expanded gives this result here. Question 14. ABC and ABD are two right-angled triangles, so that's what we see here. The angle BAC and the angle ADB is 90 degrees, so we've got 90 degrees here and 90 degrees here. AB is equal to 13 centimeters and DB is equal to 5 centimeters. We have to work out the length of CB. We have to work out this entire length. Well, for us to do that, well, what we can do is, if we find out, say, this angle here, somehow, we can use trigonometry on this larger triangle to find out this length here. So let's do that. Let's draw out the little triangle before we do anything else. So here is our little triangle. We have here D, A and B. And if we calculate this angle, well, here we have 5, here we have 13. We want to calculate this angle here. So to calculate this angle, well, we'll just add it as x over here. But we've been given the hypotenuse, we've been given the adjacent, so the cosine of x is equal to the adjacent over the hypotenuse. So here we've got 5 over 13. So if we work out what x is equal to the inverse cosine of 5 over 13, which is 67.3, etc. So here we have 67.3, etc. degrees. So if I add this to the diagram, we have 67.3, etc. So now, if we focus on the larger triangle, we have a horizontal length here, which we're calculating. We've got this over here, and we've also got this over here, okay? So here we've got the 13. Here we've got the angle of 67.3, etc. So that's this angle here. So here we've got C, A, and B. We want to calculate what CB is. Well, here, this is the hypotenuse, this is the adjacent. So what connects the hypotenuse to the adjacent is cosine. So therefore the cosine of 67.3, etc. is equal to the adjacent 13 over the hypotenuse CB. So we need to find out what CB is. So therefore CB is equal to 13 over the cosine of 67.3, etc. So if we work this out, we have 13 divided by the cosine of this, which is 33.8. So here we have 33.8. So CB is 33.8 centimeters. Question 15. A pendulum of length L centimeters has time period t seconds. T is directly proportional to the square root of L. The length of the pendulum is increased by 40%. We have to work out the percentage increase in the time period. So here, we know that T is proportional to the square root of L. And what this would imply is T equals K lots of the square root of L. Now, with the 40% increase, we know that the length is increased by 40%. So with the 40% increase, T is now equal to K lots of, well, here we're going to have 1.4 times by L. And the reason we have 1.4 is because the length of the pendulum is increased by 40%. So let's work all of this out. Well, here we can split this up as T equals K lots of the square root of 1.4 lots of the square root of L. So T is equal to, if I work out the square root of 1.4, we get 1.18, etc. So we have T equals 1.18, etc. times by the square root of L. And if we compare, rather here we've got K lots of the square root of L. So if we compare this with this, so if I call this equation 1 and this equation 2, and if we compare equation 1 with equation 2, you can see we have a multiplier of 1.18, so therefore we have a percentage increase of, well, if I multiply this by 100, we have an 18.32% increase. Okay, so we have a percentage increase of 18.32, so therefore we have 18.3 to 3 significant figures. Question 16. The histogram gives information about house prices in a village in 2015. So that's what we see here. And 20 houses in the village have a price between 30,000 and between 300,000 and 400,000, and that's what we see here. And we have to work out the number of houses in the village with a price under 200,000. So let's think about what this question wants us to do. Well, we need to find out the total number of houses in this box, and this box. Now, let's think about which formula we need to use. Of course, we know already that frequency density multiplied by the class width gives us frequency. And of course, frequency corresponds to the area. Now, with this, we know that there's 20 houses in the village that have a price between 30,000 and 40 and between 300,000 and 400,000. So this region shown in red here shows what we need to work out. So we can use this to find out the scales of the frequency density. So to work that out, here the frequency density here is equal to the frequency, which is 20, over the class width, which is between 300 and 400, so that's 100. So here we get 0.2. So what that means is, here we have 0.2. So here we've got 0.4, here we've got 0.6, and here we've got 0.8. And what we need to do is work out the number of houses in the village with a price under 200,000. So a price under 200,000, we have this blue region here. Now, of course, the area corresponds to the frequency, so we can use that to find out the total number of houses. So therefore, you can see here for the first box we have 0.14 multiplied by 100. So this is in between 0 and 100. And then we here for this middle box we've got 0.6 multiplied by 50. And then we've got the 50 from 150 to 200 multiplied by 0.8. So we've got 0.8 times by 50, and if we work all of this out, we get 84. So therefore, there's 84 houses with a price under £200,000. Question 17. Here are the first 5 terms of a quadratic sequence. We've got 1, 3, 7, 13 and 21, and we have to find an expression in terms of n for the nth term of this quadratic sequence. Well, first thing we can do is find out the difference between each of these terms. So the difference between 1 and 3 is 2. The difference between 3 and 7 is 4. The difference between 7 and 13 is 6. And the difference between 13 and 21 is 8. We now find out the difference between each of these terms. So here we've got 2, here we've got 2, and here we've got 2. And therefore, if we divide this 2 by 2, we get 1. So this means we have a 1n squared. Now, our next step is to write out the n squared terms. So for our n squared terms, we have 1, 4, 9, 16, and 25. We could continue as well, but because only 5 terms are listed here, let's list 5 terms here. We then find out the 1n squared terms. Here we have 1 multiplied by 1, 1 multiplied by 4, 1 multiplied by 9, 1 multiplied by 16, and 1 multiplied by 25. We now write out our sequence. So we've got 1, 3, 7, 13, and 21. And now we work out the difference between the sequence and the 1n squared terms. So here we get 0, here we get 3 take away 4, which is minus 1, 7 take away 9, that's minus 2, 13 take away 16, that's minus 3, 21 take away 25, that's minus 4. We now find out the difference between each of these. So you can see here, the difference between each of these is minus 1. And because the difference here is minus 1, to find out the 0th term, we do the opposite of minus 1, which is plus 1, and if we do that, we get 1. So therefore, we have n squared minus n plus 1 as our nth term of the quadratic sequence. Question 18, f of x is equal to 3x squared minus 2x minus 8, and we have to find f of x plus 2 in the form ax squared plus bx. So, f of x plus 2 is equal to 3 lots of x plus 2 all squared minus 2 lots of x plus 2 minus 8. So now we need to tidy all this up. So we've got 3 lots of x squared plus 4x plus 4 minus 2 lots of x plus 2 minus 8. So if I expand, we've got 3x squared plus 12x plus 12 minus 2x minus 4 minus 8. So if I tidy all this up, we have 3x squared, 12x minus 2x, that's 10x, 12 minus 4 minus 8, that's 0. So therefore we have 3x squared plus 10x. Question 19. Here is a right-angled triangle. All measurements are in centimeters. The area of the triangle is 2.5 centimeters squared. And we have to find the perimeter of the triangle. Give your answer correct to 3 significant figures. You must show all your working. So first of all, for this larger length, we can use Pythagoras to find out what this is. This will of course be x squared plus x minus 2 all squared square rooted. So now the area is equal to 2.5. In other words, 1/2 times by the base, which is x. So let's just put this into brackets actually. Times by the height, which is x minus 2. This is equal to 2.5. If we find out what x is, we can use this to find out the perimeter. So, multiplying through by 2, we have x squared over here because x times x is x squared, and then x times by minus 2, that's minus 2x, and if I multiply by the 2, x squared minus 2x is equal to 5, from which we see x squared minus 2x minus 5 equals 0. So now we need to find out what x is, and we can do this using the quadratic formula. So for the quadratic formula, if we have something of the form ax squared plus bx plus c equals 0, then x is equal to, if you write down the formula, minus b plus minus b squared minus 4ac square rooted over 2a. So we can use this to find out what x is. X is equal to minus 2 plus minus 2 squared minus 4 lots of 1 lots of minus 5 divided by 2 lots of 1, and of course this is square rooted. Okay, so what we can now do is work out what x is. So if we have the Casio CG, the FX ClassWiz, there's actually an equation solver here. So just type in the coefficients 1, minus 2 and minus 5. You'd find x to equal plus minus root 6, which is 3.44, etc. And we also have minus 1.44, etc. Now, because x must be greater than 0 because we have lengths, we can therefore conclude our only solution is x equals 3.44, etc. So what we can do is store this value of 1 plus root 6 into our calculator. Okay, so we have 1 plus root 6 as a solution, which is this. So now therefore the perimeter, that's going to equal x minus 2 plus x plus the bit which we mentioned here. So let's just copy and paste this. So here for the perimeter, we've got x, which is 1 plus root 6. Well, actually, let's just write down it as a decimal. We have 3.44, etc. minus 2 plus 3.44, etc. plus 3.44, etc. squared plus 3.44, etc. minus 2 squared, and here this result is square rooted. So if we work out what the perimeter is, we have this value minus 2 plus this value plus the square root of this value squared plus this value minus 2 squared. So it turns out we get 8.64, etc. So therefore we want to write this to 3 significant figures. So we have 8.64 to 3 significant figures centimeters. Question number 20. The graph shows information about the velocity v meters per second of a parachutist t seconds after leaving a plane. So we've got the velocity in meters per second and the time in seconds, and we have to work out an estimate for the acceleration of the parachutist at time t equals 6 seconds. Well, what we have to do here is draw a tangent at the point t equals 6 and then find the gradient of that tangent. So when t equals 6, we need to draw a tangent over here. So if I do that, we have the tangent at this point. So let's just show this in red. So let's see if we can make it as straight as possible. We have something looking like this, and let's just make sure it touches the curve exactly once. Okay, so let's just move it like that. Okay, so now we need to find out the gradient of this. So for the gradient, well, here we've got the change in y. Well, this point is going to be 60, and the corresponding x coordinate is 9. So here we've got 60 and then 9, and then here we've got 0 and 20. So to find out the gradient, we've got the change in y, rather here we've got 960. So we've got the change in y, 60, take away 20 of the change in x, 9 take away 0. So if we work this out, 40 over 9 is equal to 4.44, etc. So we can therefore conclude that the acceleration is approximately 4.44 meters per second squared. Now for part B of the question, we have to work out an estimate for the distance fallen by the parachutist in the first 12 seconds after leaving the plane. Use 3 strips of equal width. So here we have to split this up into 3 parts. We have, if we split up this into 3 equal parts, 12 divided by 3, that's 4. So let's draw on from here the equal strips. So that is, as we see here. Okay, so now if we join this and this up, here we have a trapezium, here we have a triangle, and here we have a trapezium. Okay, so let's just show this, and then we've got this. So now we need to find out the area of these 3 regions. So what we have over here for the first bit, well, this point is 35. So we've got the area of 1 being well, let's just write it out like this. So here we've got 1/2 times by 4 times by 35. So this is the area of 1. The area of 2, that's a trapezium. So here this point is 35, this point is 51. So we've got the area of a trapezium, which is 1/2 times by 35 plus 51 times by 4. So this is the area of 2. And then the third one, we've got 1/2 times by 51 plus, well, this point here is 54. And the height is 4. Okay, as we see here. So this is the third one. So let's just move all this to here. So if we work all of this out, we've got 1/2 times 4 times 35 plus 1/2 times by 4 times by 35 plus 51 plus 1/2 times 4 times by 51 plus 54, which is 452. So here we end up with 452, and therefore we have 452 meters. Of course, we need to recognize that the area under a curve in a velocity time graph corresponds to the distance. Question 21. The number of bees in a beehive at the start of year n is Pn. The number of bees in the beehive at the start of the following year is given by this formula here. Pn plus 1 equals 1.05 of Pn minus 250. At the start of 2015, there were 9500 bees in the beehive. How many bees will there be in the beehive at the start of 2018? So first of all, P0 corresponds to 2015. So, well, let's actually write out as 2015 corresponds to P0, and P0 here is equal to 9500. In 2016, P1 is equal to, if we use the iterative formula, we've got 1.05 lots of P0 minus 250. So here we've got 1.05 lots of 9500 minus 250. And if we work this out, well, here we can use our calculator quite easily. So let's just show it here. So here we've got, if I type in 9500 into my calculator, currently this value is stored into the answer key. So if I press 1.05 and then answer minus 250, this will mean that it takes the previous answer, subtracts 250, and then multiplies by 1.05. So here we get 9712.5. Okay. So for the next year, 2017, P2, okay, P2, this is equal to 1.05 lots of P1 minus 250. So we've got 1.05 lots of 9712.5 minus 250. So if I work this out, press equals again, we get 9935.625. And for 2018, that corresponds to P3. So here we've got 1.05 lots of P2 minus 250. So here we've got 1.05 lots of 9935.625 minus 250. So if I work this out, we get 10169.90625. So therefore the number of b's, we need a whole number, so we can round down to 10169. Question 22. D is equal to x over y. X is equal to 99.7 correct to one decimal place, and y is equal to 67 correct to two significant figures. We have to work out an upper bound for D. Well, before we do anything else, let's work out first of all the upper bound of x. The upper bound of x is equal to 99.75 and the lower bound of x is equal to 99.65. The upper bound of y, this is equal to 67.5, and the lower bound of y, this is equal to 66.5. When we come to work out the upper bound of D, this is equal to the, well, we want D to be as big as possible, so we want the largest value on the top, smallest value on the bottom. So here, we've got the upper bound of x over the lower bound of y, which is equal to, well, here we've got 99.75, and here we've got 66.5. So if we work this out, we've got 99.75 divided by 66.5, which is 1.5. So here we've got 1.5. So the upper bound of D is 1.5. Question 23. Here is a circle, centre O, and the tangent to the circle at the point 4, 3 is shown on the circle. For part A, well, here we have to find an equation of the tangent at the point P. So this is the tangent, so first of all we need to find out the gradient of the tangent, but for us to do that we need the gradient of the radius. So here is our radius, and we need to find out the gradient of the radius. So the gradient of the radius, that's equal to the change in y. So here we've got 3 take away 0 over the change in x, which is 4 take away 0. You'd find here the gradient of the radius is 3/4. And knowing the fact that the tangent and the radius are perpendicular to each other, we can therefore conclude that the gradient of the tangent is equal to the negative reciprocal, so we've got 1 over the gradient of the radius, which is 3/4. So here we've got minus 4/3. So this is the gradient of the tangent, and we can find out the equation of the straight line. One way we can do this is to use y minus y1 equals m lots of x minus x1, and if you want you can use the y equals mx plus c form. So here, if we use y minus y1 equals m lots of x minus x1, we have y minus 3 equals minus 4/3 lots of x minus 4. Now this will be sufficient as an answer, but if you want to rearrange, well, we'd have 3y minus 9 equals minus 4x minus plus 16. That's one answer we can have. Or we can have, if you want, y equals, well, here we're going to have minus 4/3x, and then we've got minus 16/3 plus another 3, well, that's going to be 25/3. So you can choose any of these answers. So let's write down y equals minus 4x/3 plus 25/3. Okay, and let's just move this slightly to the right. Question 24. A, B and C are points on the circumference of a circle, and we have to prove that the angle BOC that's this angle here, is twice the angle BAC. So first of all, this is a standard question for a proof, a circle theorem proof. So first thing we can do is start off by drawing the line OA. So that is this line over here. So you'd first of all notice that OA is equal to OB, which is equal to OC. So this line equals this line equals this line, and that's because they are all radii. Now, what else you'll find because of that is the angle, the triangle OAB, that's this one here, and the triangle OAC are both isosceles. Okay? Because this length equals this length, so this is an isosceles triangle, and this length equals this length, so here we have an isosceles triangle. And because of that, the angle OAB, that's this angle here, equals OBA, that's this angle here. So, and also the angle OAC, that's this angle here, is equal to OCA, which is this angle here. And the reason for this is the base angles in an isosceles are equal. Okay? So we've got the bulk of the information done right now then. So what we will now do is let the angle OBA equal x. Okay, so we will let this angle OBA equal x. And if we do that, this angle over here will also be x. Okay, so let's just write that down. So OBA equals OAB, which is equal to x. And with that, we can find out this missing angle over here. This missing angle here will therefore be 180 minus 2x. And that's because angles in a triangle add up to 180. So let's just write that down. So AOB, which is this angle here, equals 180 minus 2x. And that's because angles in a triangle sum to 180. Now, what we will do now is extend the line OA to OAM. So let's just show that in green. So we're going to be extending this line down here to a point, say, M. So let's just write that down. So extend line OA to OAM. That's what we see in green here. Okay. Now with this we can find out the angle MOB, which is this angle over here. This angle will equal 180 because we've got angles on a straight line. Take away the 180 minus 2x, which is 2x. So this angle here is 2x. Okay, so let's just write that down. So MOB is equal to 2x because angles on a straight line sum to 180. Now let's follow a similar procedure. We will now let this angle here be y. Consequently, this angle over here will also be y. So let's just write that down. So we will let OCA equal OAC. That's what we see here. And that's because these two are equal because base angles in an isosceles are equal. So we will let these two equal y. So what we can now do is find out what MOC is. So the angle MOC is equal to, well, before we do that actually, we can therefore say that this angle here is equal to 180 minus 2y. So let's just write that down. AOC, which is this angle here, equals 180 minus 2y because angles in a triangle sum to 180. And with this we can find out what this angle is. This angle of course will equal 2y. So let's just actually write this out here. So this angle, okay, and this angle will be equal. Let's just write them down. We've got 2x here and 2y here. So let's write that down. MOC is equal to 180 minus 2y, which is this one here, and this is equal to 2y, and that's because angles on a straight line sum to 180. Okay, so what we can also see is that the angle BAC, this is equal to x plus y. And what we also see is BOC is 2x plus 2y. So therefore BOC is equal to 2x plus 2y. And of course this is equal to 2 lots of x plus y, which is indeed the angle A plus, which is the angle BAC. So hence we've shown it. So let's just write down a concluding remark. The angle at the centre is twice the angle at the circumference. So that is the proof as we see here.